ditch day, like second semester?
Second semester.
Okay.
It's like third to last.
Well, when I was a senior, every day was ditch day. Okay.
Apparently.
That's right. Yep. Somebody help me pull down the thing. Rahul, you're doing it. Thank you. Super tall. Okay, implicit differentiation. Now, what is implicit differentiation? That's when we have an equation in x and y. Quiet, please. That's when we have an equation in x and y where it's very difficult to isolate y itself in terms of x. So let's say we have maybe an equation like y cubed plus y plus x equals 3, maybe. And somebody asked you, oh, find the derivative of y with respect to x. So find dy dx. Okay? So, technically we only really know how to find the derivative with respect to x if we're able to express y in terms of x. So, we would have to solve for y and write it in terms of x. But the problem is that's quite hard, right? I don't know how to do it. You probably don't know how to do it. And so we need to find a different way. And so that's why people came up with this idea called implicit differentiation, where you don't actually have to isolate y to just find the derivative. What you can just do is take the derivative of both sides and then solve for the derivative. Okay, so how would that look like? What we would do, we would just start with this equation, y cubed plus y plus x equals 3. And then we just take the derivative of both sides. So we add a d dx to both sides. That's our derivative function, right? Make it red. Okay, so we took the derivative of both sides. Okay, so what is the right side? Anybody?
0.
Very good. It is 0 because 3 is just a constant. So the derivative is 0.
So you just take the derivative of both sides.
That's right. And then we're going to try and solve for dy dx when it pops up. Okay?
You didn't solve the left side, though.
I haven't not yet, yes. Okay, so how do we take the derivative of the left side? Well, we first have to remember that y is actually a function of x, right? So this is kind of forcing us to use chain rule. And so this is what the derivative of the left side would be. So for y cubed, that derivative with respect to y is just going to be 3y squared, right? That's just power rule. But then we actually have to take the derivative of y with respect to x and then multiply it. So the actual derivative with respect to x is 3y squared times dy dx. That's because it's actually chain rule. Because the outside function, you can imagine, is the cube, right? And the inside function is actually y, because y is still a function of x. And so after you do chain rule, you're left with 3y squared times dy dx. And then we add, right? And then, right, we're just going to take the derivative of y with respect to x now. That just gives us dy dx. And then finally, we have the derivative of x, which is just 1, right? That's by power rule, because x is equal to x to the power of 1. And then, as Daniel helpfully mentioned, the right side is equal to 0, because we're taking the derivative of a constant. Okay. Any questions about how we got there? Yes, Tristan? Well, here, the outside function is the cube. So just think of it as, y being a function of x, and then this is cubed, okay? If we took the derivative with chain rule, then this becomes 3y squared of x. Not a multiplication, but a function. So 3y of x squared, because we're taking the derivative of the outside while leaving the inside the same, right? So the y of x doesn't change. 3y squared, and then we multiply it by the derivative of the inside, which is dy dx. Okay, so that's how we get that. Okay. Any other questions? Well, the next step is just us trying to isolate dy dx. And we do that just by solving. And so how do we do that? We first probably factor the left side. So factor out the dy dx, and we're left with 3y squared plus 1 times dy dx. And then I'm also going to move the 1 to the other side. So that becomes -1, equal to -1, because the 1 got moved to that side. Okay, and then all I need to do now is isolate dy dx by dividing both sides by 3y squared plus 1. And my answer is 1 over 3y squared plus 1. That would be my answer. Okay. So notice how my final answer is actually in terms of y. And that's allowed. That's allowed because generally a question will ask us find the derivative at a certain point, x, y. And so we'll actually know the value of y when we're looking for this derivative. So implicit differentiation, you'll end up with a function of both x and y. But this is a general process. We take the derivative of both sides with respect to x, we make sure we use chain rule, and then we try to isolate dy dx. Any questions? Yeah. Mm-hmm. Any questions? All right, then let me do some examples. I'm looking at the homework right now. I'm just going to change the numbers and do an example, okay? Can't give you the solutions directly, of course.
Are we gonna do it together or by ourselves?
What do you want?
Both by ourselves.
Okay. Okay, so try to find dy dx if y, sorry, not y equals, but 4x squared minus 5y squared equals 7. Okay. So take the derivative of both sides with respect to x, and don't forget to use chain rule, and then try to isolate dy dx. Okay. Anybody know what this is a graph of? I think it's a hyperbola, right? I think. So, the ugly way would be to try to isolate for y, but that's not going to give us a very helpful answer. Try this yourself. So take the derivative of both sides with respect to x. Yeah.
I'm kind of confused where you put the dy to dx and stuff. The dy over dx.
You're confused about
Like, where to use that stuff. Like, where do I put it into the equation? Like, I have 8x minus 10y equals 0. But I still know in there where to put the dy over dx.
Okay, that's what I mean by using chain rule. So when you're taking the derivative with respect to x of like 5y squared, that's not just 10y. It's going to be 10y times dy dx. Because y is still a function of x.
Oh, so you're like kind of distributing?
Not distributing, but this is chain rule because you have a function outside a different function. So your outside function is the 5y squared, but your inside function is y of x, because y is still a function of x. So you first take the derivative of 5y squared with respect to y, but you have to then multiply that by dy dx.
So it'd be
Yeah, that's kind of the heart of implicit differentiation.
negative 10y dy dx.
Yeah,
And for the 8x, it would be...
that's just 8x,
Oh,
because that's a function of x, right? So we're taking the derivative with respect to x, which means that we're done when we just write 8x. Okay, I'll show you guys the next step.
So why don't you do dy dx with just d over dx?
Because dy dx is actually a function. I'm just taking the derivative of both sides.
So you're just writing the d over dx just to say you can get rid of it.
Yes.
You're not actually using it as the replacement for everything. On the last one. Yeah, like in the middle there, like 3y squared. Just,
This?
yeah.
Not quite sure what you mean. Well, dy dx is actually a function that I'm solving for.
Yeah.
But d of dx is kind of like an operation that I'm doing.
So why do you like plug it in the middle of the equation?
Where did I plug it in?
So you replace it with the y.
Replace it? So I'm taking the derivative of every single term here, y cubed plus y plus x. And so that leaves me with, the derivative of y cubed, which is 3y squared, then the derivative of y, and also the derivative of x. I'm not sure what you're asking. Okay. Okay, let's go back to this example. So the derivative of the left side, so 4x squared, that's easy. That's just a function of x already. So the derivative is going to be 8x. 5y squared, that's more tricky because I have to use chain rule. So first, I'm going to differentiate with respect to y. That's going to give me minus 10y, right? But then, because I'm actually differentiating with respect to x in the end, that means that I have to do chain rule, which means I multiply by the derivative of y with respect to x. So dy dx. And then the right side is just 0, because that's a constant. Yeah.
When you're multiplying by chain rule, you take the derivative of the inside of the function, right?
Mhm.
So are you saying that dy over dx is inside the function?
I'm saying that y is the inside function.
I see.
And then I have to multiply by that derivative,
So
right?
what are you trying to find?
I'm trying to find dy dx. Yeah. So now, right, it's pretty straightforward. The next step, I just try to isolate dy dx using simple algebra. So I'm going to move the 8x to the right side. That's going to leave me with negative 10y times dy dx equals negative 8x. And then I'm going to divide both sides by negative 10y, which will leave me with dy dx equals 8x over 10y, which is also equal to 4x over 5y. 8x over 10y becomes 4x over 5y. And that's enough as my answer.
So,
I can just circle that.
we do one more. That's not that rad. Not that rad.
Okay, any questions? Any questions?
Can you do another one?
Yeah, Tristan?
Your answer doesn't have to be like a constant in variables.
I mean, it's normally not a constant, right? Okay, let's do another one. I'm looking at question 2 on the homework and just going to change some answers, change some numbers. This is a harder one, I think. Not too hard. Okay, the question is find dy dx. And here we have the square root of xy equals x cubed y plus 2. Okay, so this looks very ugly, so we definitely do not want to be solving for y here, right? Well, actually we could, but that would not be pleasant. Okay, so what I'm going to do, I'm going to take the derivative of both sides with respect to x. Let me also rewrite this as a power of half, because that's what we do when we have square roots, right? Okay. So on the left side, I am going to use chain rule, and then product rule, and then chain rule again. Okay, that's very annoying, isn't that? Okay, so the very outside function is the power of 1/2, right? So I'm gonna first do that, and that's gonna leave me with 1/2 times xy to the power of negative half. Right? So I did the outside function. And then I have to multiply by the derivative of the inside function, right? So that's going to be d dx of xy, which I have not found yet.
Would it not just be 3x squared times 1 on the inside?
Not quite, because you have to use product rule for the right side.
Why is that?
Okay, so let me do the right side. So the 2 is obviously just 0, so we can just forget about that. But the
Do you use
derivative,
the right one at all, or no?
you do have to use chain rule. Anytime you have a y, you have to use chain rule. So we're going to use product rule here because we have a multiplication of two different functions, x cubed and y. So first, we're going to take the derivative of the left side and leave the right side alone. So that's going to give us 3x squared times y. Right? Derivative of x cubed is 3x squared. And then I'm going to leave the y alone. And then I have to add, leaving the left side alone, but taking the derivative of the right side. So that's x cubed times dy dx.
Oh, so you just plug it in every time.
Yeah, whenever I'm taking the derivative of y, that's dy dx. So that's where that appears. Okay, I still have to keep simplifying this derivative of xy, right? But that's just the same, almost the same as what I just did, right? I use product rule. So I'm going to keep this 1/2 xy to the power of negative half there. And then I have to take the derivative of xy multiplied by that. So I'm going to have a big parentheses and then do product rule. So take the derivative of the left side, leave the right side alone. So that's just going to be y, because the derivative of x is 1. So that's 1 times y, plus leaving the left side alone and taking the derivative of the right side, which is y plus x times dy dx. Okay, any questions there? This is pretty annoying. And then I'm going to keep the right side alone. Kind of regret leaving this homework question in. It's so unpleasant.
Is
Oh.
this the stuff that you like?
The stuff that I like?
Yeah, when you're talking about like.
Oh, yeah, more than limits, yeah. I think integrals are the most fun, though, because they're the most creativity. Yeah.
Creativity, like drawing.
No, like, it's like there's always a trick. So that's hard, but fun. Whereas derivatives is just you plugging in the same rules over and over again, which is not as pleasant. Okay, so the rest is just simplification, which is probably the hard part, isn't it? So I'm going to expand the left side. I might go a little quickly, if you don't mind. So I've expanded the left side. And then finally, I need to isolate dy dx. So I'm going to bring all my dy dx to the left side and all the other stuff to the right side. That will leave me with this fun monstrosity here. Yeah, I see a lot of 1s and 2s and 3s. Yeah, I might just delete this question from the homework. Yeah.
dx just slow. dy dx line there.
X times y derivative in terms of x, and then x times y. What does that mean?
Here?
Yeah.
That comes from chain rule. I took the derivative of the 1/2 first because that's the outside function. But the inside function is the xy, right? So this 1/2 xy to the negative half, that comes from the derivative of this half here. But I also need to multiply by the derivative of the inside. So that's d dx of xy.
So even if you could use power rule there, like theoretically, if there's a y there, you just still need to use
I mean, yeah, because this is not just power rule. There's a function inside, yeah, of xy. Okay, so after a final round of simplification, I'm left with this wonderful answer here. Okay, it's just algebra. You could probably simplify that, but it's not very pleasant. Okay? I think I will delete this question from the homework. Okay, any questions? Let me do a question that asks you to find the derivative of a specific point, because that's quite important too. Let's look at this one. Okay, just copy it down. Or just give up. I might not have it in the homework. Okay, next one. Let's do, okay, I'm looking at question 5 on the homework and changing some numbers here. It has me evaluating dy dx at a specific point. Let me figure out the point after I change the numbers. And we have x cubed plus y cubed equals 4xy minus 1. Okay? And change my mind. It's not going to be minus 1. It's going to be minus 2. And let me try to evaluate this derivative at the point 1, 1. Okay? So you can confirm that this graph actually passes through that point 1, 1. And so I'm trying to evaluate the derivative at that point. In other words, I'm trying to find the slope of the graph, of the tangent line to that graph at the point 1, 1. Right? That's just the derivative in the end. It's just a slope, right? Okay? So what I'm going to do implicit differentiation, which means that instead of solving for y, I'm going to take the derivative first and then solve for that derivative. So I'm going to differentiate both sides with respect to x. That's always the first step. Okay. And so the derivative of x cubed, that's easy. That's just 3x squared. Power rule. But for the derivative of y cubed, I have to use chain rule, right? Because the outside function is the cube, and the inside function is y, which is still a function of x. And so that derivative is going to be 3y squared, right? Take the derivative of the cube, leaving the y alone, and then multiplied by the derivative of y with respect to x. Okay? So,
dy over dx just means slope, right? Or am I wrong?
yeah, I mean, yeah, I guess so. It's the derivative. Okay, and then the right side, 2 just becomes 0, so I can forget about that. But for 4xy, I have to use product rule, right? And so I'm going to take the derivative of, so the 4 just comes out. So I'm going to take the derivative of the left side, which is 4x, and then leave the right side alone. So that would become 4y, right? I took the derivative of 4x, which is 4, and then I left the right side alone. So 4y, and then I add, this time I leave the left side alone, so that's 4x, but I take the derivative of the right side, which is the y, right? And so that's going to be 4x times dy dx. Okay, questions there? That is the most important step of implicit differentiation, right? Understanding where the dy dx should go based on chain rule. Questions? Okay, I will now solve for dy dx just by isolating terms. So if I bring all these dy dx terms to the left side, I'm going to get 3y squared minus 4x times dy dx. And then I have to bring all the other terms to the right side. So that is going to be 4y minus 3x squared. Okay. And so my final answer for dy dx is going to be 4y minus 3x squared over 3y squared minus 4x. Okay, just divided both sides by 3y squared minus 4x. And so the final step is just to plug in my values for x and y. because I'm still trying to find the slope of that line, right? I'm still trying to find the slope of the tangent line to the graph at 1, comma 1. And so what I do is I plug in x and y as both 1, and I'm going to be left with -1,
Yep. I got that.
because it's 4 minus 3 over 3 minus 4. Because x and y are both 1, and that's just 1 over -1, which is -1. So that's my answer. Okay. And then last thing I need to comment on, the last question on the homework, it asks you to find the points at which this graph has a vertical line, vertical tangent line, or a horizontal tangent line. Okay, so a brief comment about that. A horizontal tangent line, we remember from the quiz 1, right? Horizontal tangents, those are just when the derivative is equal to 0, right? Because that means the tangent line has a slope of 0, so the derivative must be 0. Now, what is a vertical tangent line? That's a little more tricky. Because what is the slope of a vertical line? Slope of a vertical line is actually undefined or infinite. So vertical tangents occur whenever the derivative does not exist or goes to infinity. You can write it like that. Or undefined. Hopefully that's helpful. That's all I have.